Hello everyone, welcome to OneClass. My name is Shanjida. I am currently a second year human biology student at U of T. And so today I'll be going over some commonly asked chemistry questions both at the high school / college and university levels. And if anyone needs an additional help with schoolwork or needs tutoring, please check the description box below. Other than that, let's get started. Okay, so our first question here says, what is carbon fixation? Okay, so what is carbon fixation? Okay, so carbon fixation is the first step out of the Kelvin cycle. It is part of the Kelvin cycle to make basically like ATP. And so in carbon fixation, carbon dioxide, so CO2 is fixed. Basically it's fixed and it gets broken down. It's basically broken down, you can say broken down to an inorganic molecule to an organic molecule. Okay, so you're trying to make carbon molecules to an organic molecule. Okay, and so basically the process, how this works, is basically firstly a carbon dioxide basically reacts with an enzyme. Basically it's called rubisco, and so then this breaks down into two phosphoglyceride molecules, and then basically the Kelvin cycle occurs. This is where the carbon dioxide basically breaks down into an organic molecule. So basically overall overall carbon fixation occurs to make a stable inorganic molecule to become an unstable molecule, then to spontaneously break it down into two organic molecules. So basically it involves the Kelvin cycle to do this procedure. And so you can basically say that it occurs to make a stable inorganic molecule become an unstable molecule, right? And then the Kelvin cycle basically then spontaneously break down into two organic molecules. Okay, So this is basically what carbon fixation is. And yes, so they're saying the Calvin cycle is done, the fixation is done by the Calvin cycle, and yes, so this is correct. Okay, so now our second question says, what is the specific heat of ice? Okay, so basically over here we're trying to find basically the heat capacity, or like the heat that is required to change the temperature of 1 gram of ice, basically in this case, by 1 degree at constant pressure. However, this differs from molar heat capacity, because molar heat capacity, we're talking about the heat required to raise the temperature of 1 mole instead of 1 gram. So we can calculate the heat specific equation by basically the equation given where, so to calculate heat specific heat capacity, right? You have this equation, Q equals to mc delta T, okay? And so where Q is the heat absorbed, or released, basically, and the units is in kilojoules, okay? And m is the mass in grams, and then you have C. So C is the heat capacity. C is the heat capacity, basically, is the heat capacity, and this is usually given in a table, or you can't really get the heat capacity. It's usually given, and so the units for this is in joules per gram Celsius, and then your delta T is the change in temperature. In degrees Celsius. Okay, and so if you want to find the heat capacity, for instance, the specific heat, you would use Q. If you want to find the specific heat, so in this case C, you can basically rearrange the equation where Q is equal to mc delta T, right? And then you just rearrange this equation and you get C is equal to Q over m delta T, okay? And so you can find the specific heat of ice by doing so. I'm just denoting I as ice, and you have, so these values would be given to you, Q, M, delta T, and then you can find your specific heat of ice. Okay? Yes. Okay, so this is correct. So our third says, what is the difference between a solute and a solvent? And so let's say what this is basically. So when you so let's say, I'm just gonna write this out. So when you mix a solute with a solvent, you get a solution. Okay, so the mixture is called a solution. And so basically a solution is homogeneous. It is a homogeneous mixture consisting of a solute dissolved in a solvent. So basically the solute, the solute is the substance that is being dissolved, in the solvent basically. So it's being dissolved in the solvent. Whereas if you want to compare a solvent, while the solvent is the dissolving medium, so solvent is the dissolving medium. Okay, so for example, we can say that, for example, we can say our solute, we can say, for example, if you want to have a solution of, let's say, salt water, our solute in this case is salt, and our solvent is water. Okay, and so then our mixture, our solution, is salt water. Okay, this is usually a liquid. Your dissolving medium is usually liquid, and your solute could be, your solute is also is usually a solid. So yeah, so this is the difference between a solute and a solvent. Yeah, so they have mentioned an example of salt and water. Yeah, so this is correct. Okay, okay, and so our next question says, what is the molar mass of calcium? So what is the molar mass of calcium? Okay, and so in order to find the molar mass, so I'm just denoting mm as the molar mass. To find the molar mass, you can say it is equal to the number of the atomic mass. So number of the atomic mass of that element basically. And so if you recall that the atomic mass, to calculate the atomic mass, you need the number of protons plus the number of neutrons. Okay, and so this is given in your periodic table, where the number of proton is basically equal to the number of neutrons in most cases. So you will get this from a periodic table where calcium has 20 protons and therefore 20 neutrons. Okay. And so you can say that the atomic mass is basically 20 plus 20, and it's equal to 40 AMU. And so in this case, you can also say that the molar mass of calcium is also like approximately 40. So I just rounded my number. You should go with the numbers that are in the periodic table. 40.0 grams per mole. Okay. Make sure the units here, so keep in mind the units, whereas for atomic mass it's AMU, and when you're dealing with molar mass it's grams per mole. Okay, so yes, this is correct. Okay. Okay, so the fifth question says, how can I calculate freezing point depression of water? Okay, so basically when you're dealing with freezing point, you will need an equation, the equation basically for this. And so the equation, of freezing point of a substance is given by delta TF, this is your freezing point, equals to this one constant, KF times MI. Okay. So basically your delta TF is basically it's how much the freezing point is lowered basically. So it's basically the temperature. So how much the freezing point is lowered. Okay, and so your KF is a constant, and this is the freezing point depression. So this is your freezing point, depression. Oh, this is in degrees Celsius, and so this unit is basically degrees Celsius over molality. And so M, as you can probably guess, is the molality of the solution. Molality of the solution, where the units are so the units are basically it is basically mass of the solute over kilograms of solvent. Okay, and so then you have this one I factor. This is basically the number of dissolved particles. Number of dissolved particles. Okay, and this doesn't really have any units, but the I for any molecular compound, so you can say the I factor for any molecular compound is 1. Otherwise told. So basically, if they've given that the molecular compound, the I factor is 2, you would have to use 2, but usually if it's not given, you assume it's 1. And so the freezing point depression, so the freezing point depression, you can get this by basically isolating it from the equation. So we have T delta TF equals to K F MI, right? You can just rearrange this equation and you can get delta T of F over MI. But however, the KF, the freezing point depression of water, is negative 1.86 Celsius over molality. Okay, so this is usually given from literature. It's from literature, so basically this is, but the process of finding the freezing point is you have to use this equation. If it's not given and you have these values, you can find it. And so yeah, this is correct. Okay, so number 6. What is the molecular weight of sodium hydroxide? Okay, so sodium hydroxide is an ionic compound. It is a base, so ionic compound, right? It has an hydroxyl group. Just some background information. And so to find the molecular weight, they're asking for the molar mass basically. So molar mass of NaOH is equal to what basically? Okay, so now if we go to the, if you have your periodic table in hand, you can say, so you can find the individual molar mass of each of the elements here. So we have to break this, basically break the chemical formula here and to each of the individual elements and find the molar mass of each of them. So we can say that the molar mass of sodium is approximately 23.0 grams per mole. And for oxygen, it's 16.1 grams per mole. And approximately for hydrogen, it's 1.01 grams per mole, okay? And this is given in the periodic table, but also molar mass of any element is equal, basically equal to the number of the atomic mass of that element, right? Where atomic mass is equal to the number of protons plus number of neutrons, and this is given in the periodic table itself. So then if we go back to our original question, which says to find the molecular weight or molar mass of sodium hydroxide, you basically have to add what we have got for the individual elements, the molar mass, and you can say that this is equal to, so we have 23.0 plus 16.01 plus 1.01, right? So this is basically it's gonna be around 23 plus, and I get around 40.02 grams per mole. Okay. Yeah, so I just rounded my number, and you should use the numbers given in the periodic table. So the answer is correct. Okay. Number 7 says draw the tryptophan structure. Okay, so tryptophan is, so I'll just give some tryptophan. Okay, some background information. It is an essential amino acid needed for protein synthesis. Essential amino acid. So it functions for protein synthesis, so it encodes a certain protein, basically. Amino acid needed for protein synthesis. So basically it encodes a certain protein. Okay, and so to draw this structure, it says, okay, so it is made out of 2S, 2 amino, 3, 1H inodyl, 3O propanoic acid. Okay, so the structure, however, is basically this. Okay, you have a hexagon, a hexene, okay, and then you basically have pent, okay, and you have an HN over here, and you have a double bond right here, right? Okay, and then okay, and so you have basically an H2. Okay, as you can see, we have an indole group, and this is the HN. Okay, we have an amino group, which is NH2. We have a carboxyl group, which is the double bonded O, right? C double bonded O, sorry, C double bonded O. And then lastly, we have a hydroxyl group. And this is OH. And so this is the structure of basically tryptophan. Oh, and I also forgot to mention that so the chemical formula is C11 H12 N2O2. Okay, this is tryptophan. Next are, what is the molar mass of calcium chloride? Okay, so molar mass of calcium chloride, I'll just first, if we want to find the molar mass, we need to know the chemical formula of the substance basically. And so here we're dealing with calcium chloride, right? So if you recall that calcium, right, you write calcium as Ca, and it has a charge of 2 plus, and then chlorine is denoted as Cl and has a negative charge, right? So when you're writing the chemical formula, you know that you change basically the subscripts, well, the supersubscripts become the subscripts of that element, and you just basically interchange. And so you don't really write the -1, it's just negative. So you basically have CaCl2, right? And so this is the chemical formula for calcium chloride. And to find the molar mass of calcium chloride, right, you would need to first break this down into 2 individual elements and Cl2, right? Or you know what, I'll just write, it's the same thing as writing 2Cl, but when we're writing the formula, it needs to be like this. Okay, so the molar mass of calcium is 40.08 grams per mole. This is given in the periodic table. And so the molar mass of chlorine, of one chlorine atom, is 35.45 grams per mole, but however we have 2 here, so you multiply this by 2, and so you get so 35.45 times 2, and you get 70.90 grams per mole. Okay, and so now when we are trying to find the molar mass of calcium chloride, you just have to add all of this together. So you have 40.08 plus 70.9, and this would equal to plus, you have 100, and so you basically approximately get 111 grams per mole. Okay. Yeah, so I rounded my number, so I got 111, and so this is correct. Okay, so now we need to find the molar mass of citric acid. Okay, so citric acid, as you can see by the name, it is an acid. And so citric, I'll just give you some background knowledge of citric acid. And so this is basically a weak organic acid. It's found in fruits, like it is found in fruits basically. So I don't know if you've ever noticed, but if you're buying soap, you can see it says made from citric acid basically. And so it naturally occurs in fruits such as orange, grapefruit, lemons and limes. Okay, and so the formula for citric acid is citric acid. And the chemical formula is C6H8O7. Okay, and now we're trying to find the molar mass. So as you probably know, to find the molar mass for citric acid, we should first break the molar mass of. We should first break the formula down into the individual elements and find the molar masses of those individual elements first. So first off, let's find the molar mass of carbon. Alright, so 6 carbons, right, since we have 6. So the molar mass of one carbon atom is 12.01 grams per mole. And you have to multiply this by 6 since we have 6. And so you get you get 72.606 grams per mole. So this is 6 atoms of carbon. And so this molar mass of this individual, this is given in the periodic table. Okay. And so the molar mass then we should calculate is hydrogen, which is, so we have 8 hydrogens, and so the molar mass of one hydrogen atom is 0.01 grams per mole. And so you multiply this by 8, you get 8.08 grams per mole. And so the last step would be to find the molar mass of 7 oxygen atoms. So 70 oxygen, okay? And so the molar mass of one oxygen atom is 16.0 grams per mole. Again, this is given in the periodic table, and you multiply this by 7, and you get 0 times 7, you get 112 grams per mole. Okay, and so the last step would be to calculate, to find the molar mass of citric acid, which is C6H8O7, and you would add all this together. So you would add basically what we the 72.06 plus 8.08. Okay, I'll just do this. 8.08 plus 812.0 grams per mole. Okay, and you add all this together, and then you should get plus 72.06, and you should get around 192.14 grams per mole. Okay, and so the molar mass, molar mass of C6H8O7 is approximately 192.14 grams per mole. Okay, and so yes, so the molar mass is this, and the chemical formula is C6H8O7. The density, so this, you can find this from, so the density, however, is 166. You can get this from literature, it's given. And so melting point, it has a really high melting point. Since it is a hydrocarbon, well, it's a pretty big carbon chain, and so 153, so it has a pretty high melting point and boiling point also. It's 310 degrees Celsius. Okay, so I'll just write. So the chemical formula is C6H8O7, and so molar mass is equals 192.14 grams per mole, and the density equals 1.66 centimeters cubed. Okay, and then the melting point is equal to 153 degrees Celsius. Boiling point is equal to 310 degrees Celsius. Okay, and so this is the answer. Okay, our next question here says 10th question. Says, how many grams of the excess reactant remain after the limiting reactant is completely consumed? Okay, and so to answer this question, let's first define what a limiting reactant is. So basically, let's just address what is a limiting reactant. Okay, so the limiting reactant in a reaction, it dictates and limits, basically, that's how it got its name. It limits how much how much product can be formed. Right, so basically from your reactants you make your products. So you would have a certain amount of reactant to produce a certain amount of products, right? So the limiting reactant is basically dictates how much reactant you can make, and it limits that number basically. So basically when all the limiting reactants are used up, so when all the limiting reactant is are used up, basically the reaction will stop. And so so basically this is what the limiting reactant does. So when you have a certain amount of reactants in your equation, you would be able to make that much, basically that much of a product. And so when you have used all of it up, your products, you'd be finished making your products. Whereas on the other hand, the excess reactant, so what is an excess reactant? Okay, so the excess reactant in a chemical reaction is the substance that is in excess. So substance in excess. So you have a lot. Excess means leftover, basically leftover, over, or a lot. Okay, and so so this will remain this will remain even when the reaction stops. Even when the reaction stops. Okay, and this will still remain even if the reaction stops, and all the limiting reactants are used up. Okay, and so basically it is important to determine which among the reactants is limiting in order to know how much product can be formed. So basically your product is dependent on our product is dependent on the limiting reactant. Right, so basically the amount of excess reactant remained will depend on its initial concentration. So we can say that initial concentration, so this is concentration of the product so the initial concentration of the product will depend on the excess reactant. Okay, So basically, the limiting reactant is used to determine the product, so how much product can be formed, and then the initial concentration will depend on the excess reactant and the amount, so basically, and the amount that was consumed. Okay, and sorry, I don't know why I wrote antonyms. And the amount consumed of limiting reactant consumed. Okay, so this is basically the relation between a limiting reactant and excess reactants and the product. Okay, so basically the amount of excess reactant remained will depend on its initial concentration and on the amount of limiting reactant consumed. Okay, basically, yeah, I don't know why I wrote product, but yeah, the excess reactant will remain depend on its on the excess reactant and the overall consumed product. So this is correct. Next question says, what is the molar mass of a barium chloride? Okay, so let's first write out the chemical formula for barium chloride. So barium chloride. Okay, so barium chloride consists of barium and chlorine basically. And so barium, how you write barium in scientifically, basically, like the what's it called? Scientifically, how you write, like in short form, I forgot the word. It's Ba, and it has a charge of 2 plus basically. Whereas chlorine, you write it as Cl, and it has a charge of -1. And so when you're writing the chemical formula for this, you know that the charges change, they crisscross basically, and you have BaCl2. We don't really write any subscript with 1, so it's just BaCl2. We know that there's 1 mole or 1 atom of barium and 2 atoms of chlorine. Okay, so now they're asking us to find the molar mass of barium chloride. So the molar mass of barium chloride, and so if we were to find this, we can first step is to find the individual molar mass of the elements. So in this case, let's find the molar mass of barium. And so barium is in the second group, and so the molar mass of barium is 137.327 grams per mole. This is given in your periodic table. However, it is the same thing as the number of protons plus number of neutrons, which equals to the atomic mass. Atomic mass of barium. So atomic mass unit. Okay. And so the second step would be to find the molar mass of 2 chlorine atoms. And so chlorine has the molar mass of 1 chlorine atom is 35.45 grams per mole, and since in this case we have 2, we multiply this by 2 and you get 35.45 plus 2, you get 70.9 grams per mole. Okay, and then the last step would be to add all this up. So the last step is to find the molar mass of barium chloride, and you basically add 327 grams per mole, and you add this with 70.9 grams per mole, and then you'll get plus 137.327, and you get 208.227 grams per mole. Okay, and so therefore the molar mass of barium chloride is 208.277 grams per mole. When we're dealing with molar mass, the unit is always grams per mole. Okay, and so yes, I rounded, so I just left my numbers as it was, so I guess they rounded the number, and however the answer is still the same. The solution is correct. Good job. And so, okay, that was the end of our session. If you liked this Q&A, please subscribe to this channel. It's OneClass. And if you have any further questions of your own, personal questions, please check the description box below. Other than that, please like this video, comment, and this is Shanjida from OneClass. I will hope to see you soon. Bye bye.